Now, moving on, we've got Jose Berengueres, who is Professor of Design Thinking at the United Arab Emirates University. Jose studied engineering in Barcelona, holds a PhD from Tokyo Tech, and has worked in the UAE since 2011, a country which is about to celebrate 50 years of existence on the 2nd of December. So you're up for a very big party then. I know that we overlapped by 1 year. I left in 2012, so just missed you there, didn't meet you there, Jose. Now, your talk is entitled Knowledge, Data, Storytelling and Bias, and you're going to discuss how we navigate so much data. What can we trust? What sort of bias can we crop out? Over to you, Jose, for your title, Knowledge, Data, Storytelling and Bias.
Thank you very much. And I guess now I have to share the screen. Let's see, like this. Right. Can you see my slide? Yeah.
Yes.
Well, welcome. Thank you very much. How many of you have heard about death by PowerPoint and Excel and Tableau? So today I'm going to talk about how to use visualization to think and to convince. And then we'll talk a bit about biases. But first I want to play a game. Can you guess the missing word here? You can type in the chat. It's data. The thing with data is that we need data to convince people. The problem is that data usually looks like this and leaves people feeling like this. But to convince them, you need to make them feel like this. And hence, visualization can help. The problem is there's a lot of bad visualization out there. I went to the internet. This is the 100 most active Twitters. This is a chart that shows number of data scientists in the world. And this is my favorite, the superfluous chart. So I am a professor, and as an academic, I went on a quest to find out why so much bad visualization. And I found out the culprit. School dropout, never took a design course, yet most of the charts you will see in your life are made by his software. But he is not the only one at fault here. As the education system, we are also at fault because to do great visualization, you need data science skills, but we also need design skills. The thing is, data scientists look like this, and designers look like this, and they don't go to the same schools. And the schools where they teach data, they don't teach design, and vice versa. And there are very few places where they teach both well. So to fix this, I'm going to give you the 6 rules to do data visualization. Number 1, tell me a story. If you write something, some people will remember. If you make a chart of it, more people will remember. But if you tell me a story, then even more people will remember. Number 2, know the difference between data and information. Another game, can you order these 4 types of information as logically as you can? So when I give this to my students, they end up with this order. And why is that? What is the attribute of data compared to wisdom? So data is many and it's abundant. Wisdom is scarce and it's valuable, right? And this arrow here, this is what we call the arrow of value. Number 3, know how to create knowledge. This is the data, information, knowledge, wisdom pyramid. It shows the relationship between the 4 elements. To go from data to information, a way is to usually summarize with histograms, for example. To go from information to knowledge, a way to do it is through linking the information that you found to other existing bodies and thinking frameworks, bodies of knowledge. And what is wisdom? So one guy told me once, Jose, if you want to be a leader, it's not what you say, it's when you say it. And look here, there's two thinking modes needed here. One is exploratory thinking mode, what in design thinking we call divergent thinking. The other one is convergent thinking. Number 4, make it memorable. If one makes a chart and nobody likes it on Facebook, did it really happen? No. One way to help people remember things is to use pop culture. In this case, we use personas. Number 5, use narrative. What is the relationship between data story and narratives? Well, narrative is the reason why we tell. For example, here you have this tale, right? We want to tell our kids that they should not talk to strangers. But if we say that to a kid, they will not remember it. That's why we use stories. And what is the role of the data here? The role of the data, which is the details in the story, is to give credibility to the story. The narrative is the purpose, the reason why we tell the story. It works also for adults. Can you guess what's the narrative, the story, and the data in this Brexit bus? Well, the story is that we send money outside. The data is the figure. The narrative is let's take back control. And you even have a call to action here. Fake data, but it worked really well. Number 6, choose a chart that is compatible with your narrative. For example, if we ask people to visualize this data, this is gender breakdown of data scientists worldwide, we usually end up with this chart. But is it the best chart? So for example, some people will go for a pie chart and some people for the bar chart. What is the problem with the pie chart? Well, the pie chart is a metaphor for a cake. What happens when you have a cake surrounded by 10 kids? There's going to be a fight. Is the scarcity narrative, win, lose, right? What happens when you do a bar chart? Similar story. A more neutral chart for this is the stack bar, horizontal. The problem with the stack bar is it's a bit boring. What can we do to make it more memorable? Well, we could use personas, right? And remember, if nobody remembers it, did it really happen? No. So whenever you can, dramatize. Now I'm going to show you 2 examples of famous presentations that could benefit from this. A few years ago, Elon Musk was promoting solar panels. He made this presentation. He said, look at this map, look at the pixel. We just need 1 pixel covered in solar panels to fulfill all the US energy needs. This presentation was a flop. Why? Because can you really trust something that you can hardly see? And second, what land are we going to use for that? Even a few years earlier than Elon Musk, there was a German company called QCells. They used a different chart. This is called a planet chart. And here you can see how much energy hits the Earth compared to non-renewable resources. This chart is a different narrative, is a win-win narrative. Look at how much energy there is. Let's just use a little bit of it. So, same intent, 2 different charts, different result. Another one is this famous presentation by Al Gore. Here on the x-axis you have geological years, and on the red line is the concentration levels of CO2. The white line is temperature. They wanted to show that the temperature is going off the charts. And so they put Al Gore on an elevator, on a lift, to show this. This presentation is on YouTube and it has about 60,000 views. A few years later, Professor Ed Hawkins used less data and a different chart. This is called the spirogram, and posted on Twitter. It went viral in minutes. And then comes my favorite person and ignores all these charts and tells us a story. She says, I have to go to this conference in New York, but I have integrity, so I will not jet to New York like everybody else. I'm going to use a boat and I'm going to try to reduce my CO2. So here you have an example of three different ways to tell the same story, three different impacts. So recapping, tell me a story. Data is not information. Know how to create knowledge, make it memorable with pop culture, and use narrative. Choose a chart that is compatible. Now let's talk a bit about bias. I will show you one example. There are more than 200 types of biases. The thing about biases is that they are not always bad. They are good. Biases is what allows a AI system, a machine learning system, to detect a cancer early in an MRI image so we can save a life. The problem with bias is that it's bad in three situations. One is when it goes against our values. Two is when it goes against our society. And three is when it is unfair to some minority. In these three cases, we do not want biases. So here's one example. Can you guess where is this publication from? So this was published by The Economist a couple of weeks ago. And it says nuclear accidents, extremely rare. And I'm thinking, wow, how can it be? Because I already been in one nuclear accident in Fukushima. That's why I moved to Dubai. How is it possible? How extremely rare is this? So I went and did a comparison, and here you have two man-made objects that tend to melt down, a toaster and a nuclear reactor. And so which one do you think happens more often? We already know the opinion of The Economist. So I went and dig some data. So it turns out if you manufacture 1 million toasters and you sell them, 5 of those will melt down and cause a fire. What about nuclear reactors? We have made 600 nuclear reactors in the world. 5 of them have melted. What's the probability? So these are the probabilities. And looking at frequency, a nuclear reactor, we now know that it melts down every 20 years. What about a toaster? So a toaster, if you had 600 toasters and you look at them, you would see one melting down, not more often than 50 every 50,000 years. In other words, if nuclear reactors were as reliable as toasters, we would not see a meltdown more often than every 50,000 years. And so why are we in this situation, right? And this was printed 1.6 million times. So yeah, we kind of deserve it, right? Because newspapers, social media is the information system of our society, and it's the information network. And we have decided that they should look for money wherever they can find it. And that's why we're in these predicaments. So how can we fix this? How can we fix all this fake news problem? Well, we could go back to the guys that started the whole thing. Does anybody remember or recognize this person?
Tim Berners-Lee.
Thank you. Yes, this is Tim Berners-Lee, and this is his room at CERN, where I used to work a long time ago. And so maybe we could go back to these very, very bright scientists. I never met brighter people in my whole life and ask them, how would you fix this? And I think they would say something like this. If you have a big data problem, you need a big data solution. Laws alone, like GDPR, cannot do the job. So what can be done? Well, the first thing you have to start doing is start measuring. Start measuring every word and start measuring how many times each information is amplified. And this can be done. It's very easy. For example, you could go to these people that are not very interested in measuring: Facebook, Google Cloud, Microsoft Cloud, Twitter, and tell them, well, guys, since you are unable to control yourselves, we're going to do a cloud tax. We're going to take 10% of your cloud computing power, and we're going to use it to measure what you amplify and what you don't amplify. And so thank you very much. If you answer all the questions correctly, you can drop me an email and I'll send you a copy of the book upon which this presentation is based. And now we can have some questions. Back to you.
Thank you so much, Jose. I really, really loved your talk. It really, I mean, what I liked was the lack of words on it. As you've probably seen many, many times, there were so many presentations filled with words that just hurt my head. So I enjoyed that very much, and I'm sure your students enjoyed as well. I had a question for you, because obviously you've lived in Europe, you've lived now in the United Arab Emirates and Tokyo. And I wanted to know two things. Firstly is, in your living experience yourself, what are the differences in what you've seen in how data viz is represented from those various places? And the other thing I wanted to add is, I mean, unfortunately, I think you probably have a little bit of bias because you were caught up in a nuclear reaction gone wrong in Fukushima, but they are still extremely rare. So it wasn't that The Economist was looking at toasters versus nuclear reactors. They're still less than 1%. It's just that a nuclear explosion is really not a great thing. So two different questions, really. How do you eliminate your own bias? And what are the differences that you've experienced between Europe and the Far East and now the Middle East?
That's a great question. So when I was living in Japan, I saw that in business presentations, Japanese people are not afraid to use pictograms in their PowerPoints. And this is because Japanese language has a lot of homophony, and you really need visual aid to understand what's saying. Even all the time, Japanese TV will be subtitled because of that. It has an 80% homophony, meaning that every time you say a word, there's an 80% chance that there's a different word that sounds the same. And so I was shocked, because in Europe we think pictures and sketches are childish, and there's yeah, we can use pictures here, no problem. So that was brilliant. And regarding the Fukushima thing, no, a few years ago it was thought that nuclear reactor events, the mean time between nuclear reactor meltdowns was about 100 to 1,000 times higher than 20 years. But the statistics are showing something else.
Sorry, I have a comment here from the incoming Director General for the Publications Office of the EU, Hilde Hardeman, and she says, "Dear Professor, dear Jose, brilliant. What you say is common sense and obvious, but it needs to be said, and it needs to be said clearly. Thank you very much indeed for doing so." So that's high praise indeed from the incoming Director General. Another question, what is the difference between a story and a narrative?
It depends. So a few years ago, when I started researching this, I realized that there is a job called storyteller. I didn't know that. There is people that get paid to be a storyteller. And I asked them, what is the difference between a narrative, a story, and data? And they have different opinions. When we see text, media, we talk about narrative as a story. In my context, I talk about narrative as the purpose, the payload of the story. Like the Little Red Riding Hood, the payload is don't talk to strangers. The story is the book.
Now, Jonathan Swabish spoke earlier about the use of words and how we use words and the subtlety of words. And again, it struck me that perhaps with you living in Japan, just referring to the first question that I posed to you, their alphabet is already visual, as is the case for much of the Eastern countries. Do you feel that literally their alphabet helps them think in a more visual way?
Oh yeah, totally. When they do MRI scans of Japanese and Chinese people, and they scan them when a subject is listening to a word or saying a word, in Europe, only in European languages, only one side of the brain gets activated. For the Japanese and the Chinese, both sides get activated, the visual side and the language side. It's fascinating.
Yeah, it's absolutely fascinating, as was your talk. And I know people are writing into you. They want links to your book and all the rest.
All right,
So I'm sure
send
you
me
can
an email. Send me an email. I'll send you a free copy.
I'm sure you'll be deluged with more questions. And thank you so much for that talk.